Today's lesson is 9.5, titled Combinations. Combination is an arrangement or listing of objects in which order is not important. Very similar to permutation, however, order is not important is a key in this one. So there's going to be 3 steps. Step 1, find the number of permutations for the entire set. That will go on top. Step 1 is going to be the number on the numerator position. Step 2 is going to be to find the number of permutations of the smaller set. The smaller set being the numbers we have selected from that step 1. And step 3 is to calculate. Multiply step 1, multiply step 2, then do the division of step 1 divided by step 2 to get your answer of step 3. An example of this would be Jill is frosting a cake and wants to use only 2 colors. With 6 different colors of frosting, how many different pairs can she use? So, question to asking is, how many different pairs of colors can we use? And why this is a combination is because the order of the colors doesn't matter. It's like picking a pair of people. If we have red and orange, this is why I have letters down here, that's going to be the same as having orange and red. Assume that our cakes are colored in half. This might help you make sense of it. If we have orange and red, we would just flip the cake around if we wanted red on the left and orange on the right. It's going to be the same thing. So, getting on with the problem. So we're picking 2 colors. So we have 2 blanks. How many choices do we have for our first color? Well, with 6 different colors, we have 6 choices. However, we're not going to repeat a color. So once we pick our first choice, we have 1 less choice. So we have 5 choices for our second color. That was step 1. Step 2 is to find the number of permutations, meaning find the number of ways we can rearrange those 2 colors. Right here, didn't I just show you we have orange and red? Can also be rearranged as red and orange. So those 2 arrangements are going to give us the exact same pair. So we need to divide by that to make sure we're not having multiple answers that are the same exact answer. So dividing by 2 times 1, because we have 2 colors, so we have 2 choices for the first spot, now that we have the color chosen, and 1 choice for the second spot. So now doing the multiplication, 6 times 5 is 30, 2 times 1 is 2, 30 divided by 2 equals 15. So there's 15 ways or pairs of colors we can have. Now, showing you how this works on the bottom here. So if we have red, red can be with orange, with yellow, with green, with blue, and also with purple. So that's 5 right there. Our next option is then going from orange. Well, can we go back to red? No, we already have that pair right here. So we're going to go from orange to yellow, orange to green, orange to blue, and orange to purple. And that was, I count, 4. Now we have yellow. Can we go to yellow to orange or yellow to red? No, because we already did that here, and we already did that here. So we're going on yellow to green, yellow to blue, yellow to purple, giving us 3 more. And the whole reason why we can't go back to orange is because we've already done that one. Because yellow-orange is the same thing as orange-yellow. Order doesn't matter. On with green, we have green-blue, green-purple, which is 2. And lastly, we have blue-purple. So if we add all those together, 5 plus 4 plus 3 plus 2 plus 1, we're going to get 15. That would take a lot more work than doing the formula up top here. So we're going to continue using the formula up top here. However, seeing how that worked down bottom may help you understand why we are dividing by 2 times 1 here on the bottom. The different number of arrangements, we can arrange red and orange as orange and red. Now, how many ways can a coach select 5 players out of a team of 10 players? So, again, this is a combination because order doesn't matter. Think about it this way, if this helps you out as well. If we have say we have 3 people in a group. Say we've got Mike, Mark, and Jack. Is that going to be a different group if we pick Mike, Jack, then Mark? Is that going to be the same group, right? Yes, they're the same group. Order's not going to matter in how these groupings are made. Since position doesn't matter and order doesn't matter, then that's why we have to divide by the number of ways we can arrange the group. So we have 5 players we're choosing, so we're going to have 5 blanks. How many choice do we have for those players? Well, this is going to be the larger number of the entire set. So we have 10 players that could be the first position, 9 left for the second, 8 for the third, 7 for the fourth, 6 for the 5th spot on the floor. Then we're divided by, again, we're going to have the same number of blanks. We're going to have 5 blank because now we have our 5 players picked. How many different positions can they be in? So spot 1, we'd have 5 options. Spot 2, we'd have 4 options. 3 would be 3 options. 2 would be 2. 4 would be 2 options. The last spot, we'd only have 1 person left. Now, we can multiply it out and divide, but there is a quicker way. This is just like looking at a big fraction. So we can simplify this before we even multiply. How can we do that? Well, as long as we divide the bottom by the same number we're dividing by the top, we're going to keep equal to what we were starting with. So on the bottom we have 5 here. 5 goes into 10 2 times. So dividing both the top and bottom by 5, I'll have 2 left out of that 10, and my 5 is gone to 1. Once we're at 1, we can't simplify any further because we're looking for a denominator of 1. Next we have 4. Well, 4 goes into 8. So we're going to go dividing by 4, we get 1. Divide 8 by 4, we get 2. Now we're on to 3. 3 is going to go into 9 nicely. And we'll have 3 goes into 9 3 times, and 3 divided by 3 is 1. Now we have 2 on both the top and bottom, so we're going to divide both those by 2, and our 10 is now gone. Now we have all 1s on the bottom, so we're going to have 1 on bottom, and we've got 3 times 2 times 7 times 6 on top. So we get out the calculator, 3 times 2 times 7 times 6, and I get 252 different combinations. So 252 over 1 is 252 teams. Now, what if we were choosing 4 players out of a team of 8? Say we're a golf coach and we're taking a foursome. So again, order doesn't matter, but we have 4 blanks because we have 4 members of a team we're choosing, and we have 8 choices for that first player, 7 left for the second, 6 for the third, and 5 for the fourth. Why are we going down by 1 each time? Well, we're going down by 1 each time because once we pick 1 player for the first position, there's only 7 players left standing for that second position. Once we pick a second one, now we have only 6 left standing for the third position. And once we pick him, then we're down to 5 players standing left for that fourth position. On bottom, then we're going to see how many different ways can we rearrange those 4 players once we have them. With 4 blanks matching the number of blanks we have on top, we've got 4 options for spot 1, 3 for spot 2, 2 for spot 3, and the last person standing for spot 4. Now we can divide. 4 goes into 8 2 times. 3 goes into 6 2 times. 2, we'll cancel that 2, so now we have 1. And now we have 7 times 2 times 5. 7 times 2 is 14, and 14 times 5 is going to give us 70 teams that we can make. Next question is to tell whether each problem is a permutation or combination. So, big thing to ask here again is permutation. What's the difference? Permutation means order matters. So, if it helps you think about it, think, well, let's see if we can switch the numbers or the pairings around. Does it mean something different? If it does, then order matters. Combination is going to be where order doesn't matter, as we've done the whole day. So when order doesn't matter, we have to put a line, because then we're going to have to divide by the number of ways we can arrange the set on top. So, in how many ways can a password be made of 4 different numbers? So numbers are digits. Once we hear that word, we have to think 10, because digits means 0 through 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and our 10th number is 0. So again, digits mean 10. But back to thinking, does order matter in a password? Well, if we're using digits, is 1, 2, 3, 4 the same password as 2, 3, 4, 1? No, it's not. If your password is 1, 2, 3, 4 and you type 2, 3, 4, 1, you're not going to get into your account. So, permutation, because order matters. So, now we know it's a permutation. We're going to have 4 digits, and none can be repeating. So added that note of no repeating. So again, digits, we have 10 options, because 0 through 9 are 10 different numbers for our first option. After we've chose one number, we have 9 left for the second, 8 for the third, and 7 left for the fourth. Multiplying this out, we're going to get 5,040 different ways. Double checking that, we've got 10 times 9 times 8 times 7. That gives me 5,040. Moving on. Now we have how many ways can 5 guppies be placed in a bag out of 12 guppies in a bowl? Does order matter here in how the fish are put in? The answer is no. Because for one, whenever you're making a group where there's not a title or position, it's going to be a combination, because order doesn't matter when you're making a group unless there's titles. So in this case, order doesn't matter. However, if you're making a group of a president, vice president, and maybe a police officer, or an officer position of some sort, then order might matter, because if you're picked versus president, you have a lot more power than you do if you're vice president. But in this case, picking fish out of a bag doesn't matter how they're in there. So, combination means we need to draw a line. How many fish are we choosing? We've got 5, so there's going to be 5 blanks. How many can we choose for the first position? Well, we have 12 fish, then 11 once we have the first chosen, 10 are left after the first 2 are chosen, 9 are left after the first 3, and 8 after the first 4. On bottom, we're going to have 5 blanks as well, because now we have 5 fish in there. How many different ways can they be rearranged in the bag? 5 for the first spot, 4 for the second, 3 for the third, 2 for the fourth, and one last one for the fifth. Now we're just left dividing. Now, 5 goes into 10 twice. 4 and 3 are going to both go into 12. 4 goes into 12 3 times. 3 goes into 3 once. So now we got rid of a complete number. We don't need to multiply by 1 here, because we know any number times 1 is going to be itself. So now we're down to 11 times 2 times 9 times 8. Well, we have a 2 here on bottom and top, so let's cancel that. Now we're left with 11 times 9 times 8. 11 times 9 is going to be 99. 99 times 8 is going to leave us with 792 ways. One last question here is find out how many different ways can a group of 2 be made from 8 students. So we're making groups of 2, so we have 2 spots. How many students? We have 8 choices for the first spot, 7 for the second, and there's 2 different ways this group can be arranged. We can have 2 people for the first position, 1 for the second, so dividing both the top and bottom by 2, you get 4 times 7 will give me 28 groups of 2. Or 28 ways. The last one we have, how many different ways can 12 cheerleaders group into a 3-person pyramid? So, we have 3 people we're choosing, and then we're going to have 3 different ways, several different ways we can arrange that pyramid. So, we have 12 options for the first person, 11 for the second, 10 for the third, because that's our big. We're starting with all our cheerleader options. Once we have those 3 chosen, we have 3 options for the first position, second for the second position, and 1 left for that third position on top of the pyramid. Now doing our math here, we can simplify, dividing both by 3, we get 4 on top, 1 on bottom, and dividing both by 2, 2 goes into 4 twice, so now I have 2 times 11 times 10, so that's going to give me 22 times 10, which is 220 groups. If you need any more examples, feel free to check out the peer tutors online, as well as the peer quizzes as well.